Hi everyone. This is pre-class video on module 1 representation of power system components. This is session 4. So myself Dr. M.J. Chandrasekhar, Associate Professor, Department of EEE, SJB Institute of Technology. In this pre-class video, I will be solving two problems on formation of reactance diagram for a given power system one-line diagram. So here I will be solving some numerical problems on finding the reactance diagram of the system. So here I will be showing you in this slide a description of the power system for which it is required to find the reactance diagram. Let us read this problem first to understand, and then let us write the solution for this. A 33 MVA 13.8 kV 3-phase generator. Let us write the equivalent circuit for this. One line diagram of this. So a 33 kV single phase. Here we have a generator of this rating, that is 33 kV, and it has a reactance of this much. So generator, it comes with 33 MVA 13.8 kV and 3 phase, and its subtransient reactance X double dash is equal to 0.5%. This is given. A generator supplies motor through a step-up transformer, transmission line and step-down transformer. That means here step-up transformer, transmission line and step-down transformer. Step-up transformer, T1, T2 and transmission line. So the motor, it supplies a motor. So this is motor, this is generator. Okay. Generator supplies motor through two transformers along with the transmission line is given. So here the ratings of the motor is 25 MVA 6.6 kV and its subtransient reactance is 25% is given. 25% is given. Draw the equivalent per unit impedance diagram by selecting 25 MVA 6.6 kV on a base values in the motor circuit. That is, this is motor base values. Rated values are taken as base values. It is told that how to select the base values. So either they will be giving this information or we have to assume. Here it is clearly given that the base values you have to choose as the generator rating as base. Now the step-up transformer, see here step-up transformer and transmission line, step-down transformer ratings are clearly mentioned. Transmission line is of 75 kilometer and positive reactance is 0.8 per kilometer and resistance is this much. So that means ZL is equal to R plus JXL. It is the formula, impedance formula. See, this is 75 kilometer. So 0.8 ohms per kilometer into how many kilometers? 75 kilometers. This 75 kilometer get cancelled, you will get some value, that is 75 into 0.8 ohms. Similarly, the reactance, this is resistance RL total, XL total is equal to, it is 0.5, 0.8. This is positive sequence reactance, this is X, this is R, this is 0.2 ohms per kilometer. How many kilometers? 75 kilometers. Kilometer get cancelled, you will get 0.2 into 75, some value you will get, that is RL. So this is how you can find the transmission line total resistance and reactance. And similarly transmission line transformer also given, this is transformer rating is given. Similarly transformer 2, that is step down transformer, it is something, it is given somewhat different. Like transformer 1, if you see, that is step up transformer, it is 3 single phase units connected in delta. So I will tell you this, how to do this. So clear all, yeah. See here step up transformer is there, no? Step up transformer, yeah. Step up transformer How it is? Three phase rating I should write. It is star delta, delta star. Each is 10 MVA. It is clearly given 0.5 reactance. Three single phase units are connected in delta star. While step down transformer, three single phase units connected in delta star, each is having a rating. So we have to convert single phase rating into three phase. But in the first case, they are not given. 0.5 leakage resistance. Directly they are given, that is, its rating is 10 MVA, 13.2 bar 6.6 kV, and 7.7 is the percentage is the XT1 reactance, subtransient reactance. But here they are given delta star, delta star. So the first we have to write the one line diagram. Thereafter you can write the ratings. I'll write the one line diagram here. So we have a generator. It is supplying through two transformer with transmission line to the motor. Here motor. So generator rating I will write from the previous given problem, 33 MVA, 13.8 kV, 3 phase, reactance is 0.5%. Similarly, the motor is 25 MVA, 6.6 kilovolt, 25% reactance. 25%. Next to transmission line, I told you how to calculate the ZL in the previous. Next to transformer 1 and transformer 2 is the problem. See here, it is doing the function of stepping up. This is LV, this is HV. This is doing the function of stepping down the voltage. Accordingly, you have to copy the rating from the given problem. See, in the given problem, they have given the step-up transformer bank as 3 single phase units connected in delta star. Each is 10 MVA. Each is 10 MVA. It is also given on a single phase. So, single phase rating is given. Single phase rating is given. So, that is 10 MVA, 13.2 bar 6.6 kV and reactance is 7.7. Reactance is 7.7 and 0.5 reactance resistance leakage reactance is 0.5%. Only this we won't consider, we will consider only the reactance. So I want to convert this into 3 phase. How to convert I will tell. See this one. So its function, it is given 13.2 bar 6.6. For that they have mentioned that is step up transformer is delta star. This is delta, this is star. So 6.6 comes here, LV side. Bar 113.2 kV. 13 is the delta, that is 6.6 is star. Okay, this is delta star. Suppose if you want to convert into 3 phase, 10 MVA becomes 10 into 3, that is 30 MVA. 30 MVA. Okay. Next to star, only the voltage changes. Delta means line and phase remains same. Therefore, it is 13.2 bar 6.6 is there, no? For that root 3 you multiply. root 3 we have to multiply. Here we have to multiply root 3 star. Delta means line voltage and phase voltage are same. This how you have to convert single phase rating of 3 units to 3 phase. Next to transformer 2, let us write the single phase rating of this machine. Here it is 8.33 MVA, 8.33 MVA and 110 bar 13 3.98 kV and reactance is 8%. Resistance we don't consider, only reactance you consider. So how to convert into 3 phase? See here this function is HV side is how much? The given winding connections are delta star. This is delta, this is star. So delta is 110. This is 110 kV delta bar 3.98 kV. So 110 is delta, this is star. So 3 phase rating, if you want to convert, what we have to do? 8.33 multiplied by 3, 8.33 multiplied by 3 MVA. So power means you multiply by 3. Voltage, if you want to take 110, delta means remains same, star 3.98 into root 3. Star means you have to multiply with root 3 to convert into 3 phase. And reactance you should not multiply with 3. Here is also reactance is 7.7 only. Here is also reactance is 10% only. This is how we can convert single phase rating into 3 phase. And also it is mentioned that the base values, see I will take a different color to mark the base values. So I will take blue color. Yeah. So here SB is given 25 MVA. You have to consider it motor rating as base. Therefore VB is also 6.6 kV. So here the whole power system, if you see how many parts it has. Wherever transformer comes, it divides the power system. See here, this is the one power system. Here transformer divides. This is first part of the system, and from here to here, that is the second part of the power system, and from here onwards, third part of the power system. Base values we have to find for each of the parts of the power system. Here base voltage is known. By using this you can find the base voltage. Base power remains same for all the power system components. Base power remains same. Base voltage, here you can find base voltage in this part is equal to base voltage on the previous part multiplied by transformer rating of this, that is 110 divided by this. We should not take the single phase rating. This is into root 3, that is 3.98 multiplied by root 3. So one thing you keep it in mind, that numerator and denominator voltages should be of same range. Okay. This is how we can find the base voltage. Let us take this value is x kV. Okay. Next we have to find the base voltage in this part. How to find this? Base voltage in this part is given by base voltage on the previous part divided x multiplied by, this is x value, multiplied by the voltage 6.6 andre. Here the lower voltage is how much? 6.6 into root 3. Same range we have to consider, and then 13.2. So this is how we can find the base voltage on the generator side. If you know the base voltages in different parts of the power system, your problem is almost solved. So next let us write the calculations for the reactance values. Before that, let us write the reactance diagram for the given power system. So the given power system reactance diagram, we have first generator, next we have transformer, next one more transmission line, then one more transformer, and then we have a load of this kind. This is motor, this is generator, this is transformer 1, this is transmission line, and this is transformer 2. So, for this we have to find the reactance values. We know the base values in the previous slide. So, this is Eg, this is Em, no need to find. So, we have to find the reactance of the generator 1 on common base is equal to the rated value into SB by SR into VR by VB whole square. So, this is the rating given value for generator is 0.5, SB remains same, SB is generator load value, that is 25, and generator rating is 33, this is SB 25 chosen. VR, so generator is generator voltage is 13.8 divided by VB, base voltage on the motor side we calculated. So, that value you have to consider whole square. This is nothing but the reactance. Similarly, you can write the calculation for transformer 1, transformer 2 and the motor. Same formula we have to use, and base power remains always same, and rated value of that component we have to consider. Rated voltage we know, for generator one value will be their voltage. For transformer there are two values of rated voltages on LV side and HV side. What you do is, if you consider the rated voltage on LV side, you have to consider the base also in the LV side only, so that the voltage values will be almost same. So, that you keep it in mind when you are calculating the reactances on the common base. For the transmission line, since it won't have any power, the formula for transmission line per unit calculation is actual value divided by base value, ZB, ZR. We know ZR, R plus Jx we found, write that, and VB square by SB is the formula for ZB. In the transmission line, we know the base voltage and SB remains same for all the components. Use this formula and find this. So, with this you can easily calculate the reactance diagram values from the given problem description. So, this can be easily done. After that, we have to consider this power system. Example 2, this is assignment. All of you can go through this problem description. In the same lines you can do the problem. Okay.